Lesson 5-6 is all about the transformation. When you're on an amusement park ride, you're undergoing a transformation. A transformation is a change in a figure's position or size. Ferris wheels and merry-go-rounds are rotations. Free fall rides and water slides are translations. Translations, rotations, and reflections are types of transformations, just like the Transformers movies. They go from cars and trucks and boom boxes to robots, so they're transforming. Well, that's what we're going to do here too. The resulting figure is called the image, and the image of a translation, rotation, or reflection is congruent to the original figure. So when we're doing a translation, we also call it a slide. A rotation, we're turning it, and a reflection, we're flipping it over some line. But the image is the same shape and same size as the original. So let's go ahead and look at a couple of these. A translation slides a figure along a line without turning. The table below here shows how you can perform translations on the coordinate plane. So if we're going to move right a units, you're going to add, fill this in, a to each x coordinate. So what we're going to end up getting is x plus a comma y. That's our new coordinate. And if we're going to move it a units to the left, we subtract a from each x coordinate because the x moves it left and right. So it's going to be x minus a. So the original xy becomes x minus a comma y. If we're going to move up, then that's going to affect the y because the y is up down. So if we move up b, we're going to add b units to each y coordinate. So it's going to be x and then y plus b. Make sure you're filling these in. And if you move down b units, you're going to subtract b from each y coordinate. So it's going to be x and then y minus b. All right, let's do some of these. So here we're going to move this 3 units left and 9 units down. So my xy, if I'm going to go 3 units left, left is subtracting, so I'm going to make this x minus 3, and 9 units down, down is also subtracting, so 9 units down is going to be y minus 9. So that's all I have to do for these now. I have taken it upon myself to go ahead and give you these coordinates. So I'm going to take -1 minus 3 gives me -4. So let me write this in here, and I want you to do this, at least for the first one. This was whoops. Well, I guess I can just put it in here. -1 minus 3. And then the y coordinate is y, which is 4 minus 9. 4 minus 9 is -5. Do the same thing here. 3 minus 3 is 0, and 6 minus 9 is -3. And for z, 2 minus 3 is -1, and 2 minus 9 is -7. And the one thing that I should have slid in here, so let's go ahead and put it right in here. We've referred to this before. We call the new one the image. We put a little apostrophe up here. It looks like a prime. I mean, that's what it is called. It's called a prime, but it looks like an apostrophe. So these are all transformed. So it's no longer x, it's x prime. So we have -4, -5. There's x prime. 0, -3. There's y prime. And -1, -7. There's z prime, and let's go ahead and connect them. And you can see that they are congruent, and it has shifted this entire first figure left 3, down 9. Let's go ahead and try this one. We're going to shift 2 or 3 units right. So right, we're going to add 3 and 6 units up, so we'll add 6 to the y since it's up. So this is going to be s prime. -3 plus 3 is 0. and negative 5 plus 6 is 1. And t prime, 2 plus 3 is 5. Negative 5 plus 6 again is still 1. And u prime, 2 plus 3 is again 5. Negative 2 plus 6 is 4. And v prime, negative 6 plus 3 is negative 3. And again, negative 2 plus 6 is 4. So let's go ahead and plot this. So I have 0, 1. There's s prime. 5, 1. There's t prime. 5, 4. U prime. And negative 3, 4. V prime. Oops. And I can tell that my trapezoid has been shifted right and up. So there's a translation, also known as a slide. So make sure you write that word next to it, slide. All right, next we're going to look at a reflection. A reflection flips a figure across a line to create a mirror image. In the example shown over here, the triangles are reflected across the y-axis. If we were to fold this right across the y-axis, these two triangles would lie perfectly on each other. Notice that the x-coordinates of the corresponding vertices are opposites. 3, negative 3, 1, negative 1, 1, negative 1. So this suggests the rule. The y-coordinates are the same, so this suggests a rule that can be used to reflect figures across either axis. So if it's across the x-axis, you're going to multiply each x-coordinate by negative 1. So this becomes negative x, comma, y. And really that means opposite of x. If it's already negative, then you change it to a positive. And if we want to flip it across the y-axis, we keep the x's, multiply the y's by negative 1, so those become the opposite. So this means the opposite of y. So let's do a couple of these. All right, we have this quadrilateral, and we're going to flip it or reflect it across the x-axis. So across the x-axis, remember, across the x-axis, the y is what becomes the opposite. So we're going to make this x and then the opposite of y. So a prime is 2, positive 6. B prime is 1, positive 1. C prime is negative 4. Well, the opposite of 0 is still just 0. And D prime is negative 2, positive 3. So let's go ahead and graph this. 2, 6. This is A prime. 1, 1 is B prime. Negative 4, 0 stays right here. So that's C prime. And negative 2, 3 is right here. That's D prime. Oops. And if I were to fold it across the x-axis, this figure would lie right on top of that one. Now let's go across the y-axis. When you go across the y-axis, the x becomes the opposite and you keep the y. So M prime is positive 1, 3. Come on. N prime is negative 1, 6. P prime is negative 5, 6. And Q prime is negative 4, negative 2. All right, so let's graph this. 1, 3. There's M prime. Negative 1, 6. N prime. negative 5, 6, P prime, and negative 4, negative 2, Q prime. And again, if I were to flip this, let me see if I can make this look a little better. There we go. If I were to flip this over the y-axis, they would line perfectly up on each other, the two quadrilaterals here. Okay, next we have a rotation. A rotation is also called a turn, and it turns a figure around the point. And the point is called the center of rotation. So in the example here, the triangle is rotated 180 degrees around the origin. Notice that when we rotate 180 degrees, in this case we're going counterclockwise, but really 180 degrees in both directions, you're going to end up in the same spot. But here, if you notice, the x and y coordinates are opposites. A was 1, 3, A prime is negative 1, negative 3. B was 2, 1, B prime is negative 2, negative 1. C was 1, 1, and C prime is negative 1, negative 1. So 180 degrees, you multiply both coordinates by negative 1, so it's going to become negative x, negative y. 90 degrees clockwise, I always think of it like this. 90 degrees clockwise, we go this direction. So I'm going to flip the x and the y, and then that the new y coordinate, which is x, becomes negative because I've moved it from here to here. So here it's saying multiply each x coordinate by negative 1 and then switch them. Okay, it's the same thing, but it becomes y comma opposite of x. Counterclockwise, you do the opposite. So I'm going this way. I'm still switching the x and the y, but now my y becomes the opposite. Here is saying multiply each y coordinate by negative 1, then switch them. So it's, again, the same thing. Negative y comma x. And you have to remember the negative means take the opposite. So let's try a couple of these. Okay, we're going 90 degrees clockwise. So clockwise, this direction, we multiply the x by negative. So this is negative x, and then we flip-flop the position. So it's going to be y, negative x. Okay, so we flip-flop them to negative 6, but this one becomes the opposite. Oops, that was j prime. K prime, I flip-flop them. 6, negative 6, but then this becomes the opposite. L prime, again flip-flop them, 6, negative 4, but that becomes the opposite. And M prime, 2, negative 4, and again the second coordinate becomes the opposite. So let's graph this. We have 2, 6, 2, 6, this is J prime, 6, 6, K prime, 6, 4, 6, 4 is, nope, that's L prime, and 2, 4 is M prime. So it has rotated clockwise. It's gone from here and it's rotated. Now this is something that's kind of cool. For every vertex, when you draw it, because we're really rotating around the center, if I draw from M prime to the origin and M to the origin, it's going to make a 90-degree angle. Same thing as if I did J prime to the origin and J to the origin. And the same thing with the K and the L. It will always make a 90-degree angle when you connect the corresponding original vertex with its image vertex if you do a 90-degree rotation. Let's do 180 degrees over here. Remember, we just take the opposite of x and the opposite of y. So A prime is 6, 5. B prime is -1, +4. And C prime is -1, +6. So we have 6, 5, -1, 4, and -1, 6. Oops, I don't want green. And here, this is kind of cool as well. If you take, let's say A to the origin, and then A, well, I did it backwards, A prime to the origin, A to the origin, you're going to get a straight line, which, oh, that's 180 degrees. And the same thing will happen with the other two vertices. If I did B to the origin, to B prime, etc., I would still get a straight line. All right, here's your assignment if you want to get started. And I will go ahead in class. I should have already today passed out the graph paper that goes with this in case you're interested in getting started early.